Hello there. In physics, you are very familiar with the concept of gravity. We've been talking about gravity for several years now in our physics class. However, what we've been doing is we've been using gravity on Earth. We've been using F equals ma, and just saying that on Earth, gravity is 9.81 meters per second squared down. This is a good and very useful property that we can use when we're talking about grade 11 physics. However, in grade 12 physics, we want to ask the question, why? What's going on here? And can we say more about gravity? Why is the force of gravity 9.81 newtons per kilogram? Part of that has to do with the units we choose. However, there's something a little bit more important going on. Newton's law of universal gravitation states that the force of gravity between two objects is proportional to this mass of those two objects. In other words, if you have heavier objects, more massive objects, they will exert a stronger gravitational pull on each other. As well, if you have objects that are closer together, they will pull on each other stronger. So the force of gravity is proportional to the inverse square of the distance between them. Now, this may sound really similar to the force between two charges, which we looked at earlier. The force between two charges is proportional to the strength of the charges, as well as inversely proportional to the square of the distance between charges. So this universal gravitation is a very similar concept. Now, when we're talking about universal gravitation, there's a really straightforward formula that we look at. This is the formula. The force of gravity is equal to a gravitational constant times the masses of the two objects. Those are m1 and m2. So m1 might be the mass of you, m2 might be the mass of the Earth. And this is divided by the radius squared. Now, importantly for this is the distance between centers. So the force of gravity on you on Earth's surface is our term in that will be the distance from you to the center of the Earth, or in other words, the radius of the Earth. If we're talking about objects in space, you're looking at objects or distances between the centers of those objects. If you're given distances between the surfaces, you'll need to add the radiuses in there. So the force of gravity is equal to the masses multiplied divided by the square of the distance between them. This G term is a universal gravitation constant. Now, this explains and talks about how strong gravity is. Notice, this term is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. These are a little bit weird units, but that's fine. The important thing is that this is times 10 to the negative 11. That means that gravity is actually very weak. You remember when we looked at forces between two charged objects, the constant in there, K, is 8.99 times 10 to the 9th. That's a huge difference. 10 to the 9th versus 10 to the negative 11th. An immense distance or difference between these two. So gravity is far, far weaker than the force of electromagnetism, force between charged objects. Once you know this formula, you can use the force of gravity in any of the other formulas that we've got. If you want to find the acceleration due to this, you can do that. You know F equals ma. If you want to find the work done by an object, you can do that. You know that work is force times distance. You can do all of your formulas. The force due to gravity, however, we can calculate from the masses of two objects. So if you put two bowling balls in space and allow them to attract each other, you will be able to calculate the force due to gravity between them using this formula. I hope this helps. Have a great day.